Welcome to Saxon Math, Course 1, Lesson 19. Make sure that you have the supplies that are needed in order to do your math. Today we're going to talk about factors and one of my favorite things, which is prime numbers. So a factor, when you have a whole number, let's say just the number 4, and you want to find out what is a factor of 4, you'd find out what numbers go into 4 without a remainder. For example, 4 divided by 4, 4 divided by 1, 4 divided by 2. So 1, the number 1, number 2, and number 4 are all 3 factors of the number 4. And then when we have counting numbers that only have 2 factors themselves and the number 1, then we call them prime numbers. And the number 5 is an great example of that, because the only thing that works with 5 is 5 and the number 1. Those are the only 2 things that'll go into 5. And then counting numbers with more than 2 factors, we call them composite numbers. So 4 is composite. What do you think number 3 would be? Would that be prime or composite? Yeah, it's going to be prime. You're right, because only 3 and 1 will go into 3. Nothing else goes into it. But like I said, 4 is not prime. It is composite because you have number 4, you have the number 2, and you have the number 1. See here, there's only 2 here, only 2 here, but there's 3 here. Okay, there could be 8, there could be 20, but if there's more than 2, it's composite. So if you recall from lesson 2, that a factor is one of the numbers multiplied to form a product. So 2 times 3 equals 6. Those are factors of 6. 1 times 6 is 6, so 1 and 6 are factors also. So that's what I just explained to you about the 4. Same thing with the number 6. So all the factors of 6 are the numbers 1, 2, 3, and 6. Those are called factors. So and we can illustrate factors of 6 by arranging it in tiles, right? Just to help us to see what it looks like. So whenever we arrange these tiles, they have to be equal. You can't have a set. Like you couldn't have another box over here, because that wouldn't work. They have to match up exactly and have a partner. So in this case here, we can see that here's our 6 and our 1. Those are both factors of 6, because there's 6 squares. And then over here we got 6 squares, but we kind of changed it a little bit. This time it's 2 times 3. So the number of tiles along the sides of these rectangles, 1, 2, 3, and 6, are the 4 factors of the number 6. So if you're to do the same thing and you're to do the number 2, real simple one, right? The only problem, but watch what happens with number 2. You have the number 1 and you have the number 2. Is there any other way we can do that? You say, oh yeah, we could do it like this, but are we really changing anything, or we've just taken that first one and turned it vertical? This is still 1 and 2. So guess what? Is 2 composite or is 2 prime? Yeah, 2 is prime, because it only has the numbers 1 and 2. It doesn't have more than 2 factors, which would make it composite. It only has 2, the number itself and the number 1. So it would be prime. So the number 2 is prime. So what are the factors of the number 10? Go ahead and stop the video and see if you can write these for me. Yeah, you should have came up with 1, 2, 5, and 10. Now, there's a couple of ways that you could do this. I'm going to back up just a little bit, just so we can have a little bit more to look at. There's a couple of ways we can do this. One way I like to do it is we go factors of 10, and we do it like this. And we go 1 times 10, 2 times 5. Right? Those are all, is there anything else that'll go into 10? There's not. Another way that we do that is we go 1 and we go 10 like this. And we go number 2, and 2 will go into 10. That equals 10. Is there any other number that'll go even into 10? There's not. So there's our factors of 10 right there. And we'll talk more about that in this actual lesson too. All right, so let's get going again. So we're back to here. So example number 2, how many different whole numbers are factors of the number 12? All right, so you should have came up with 1, 2, 3, 4, 6, and 12. And you could have used the tiles like it shows here on the screen. You could have also have done the rainbow, did a 1 and a 12, a 2, yeah, a 2 will equal a 6. How about a 3? Does 3 go into 12? Yeah, 3 times 4 equals 12. And then you have 4 and 3, so that doesn't work, so we're done. 1, 2, 3, 4, 6, and 12. Here we list the first 10 counting numbers and their factors. And you'll notice that the ones in the turquoise are prime numbers. The other ones are all composite numbers. The only one that's an exception to all the rules is the number 1. The number 1 isn't prime and it is not composite. It doesn't fit either rule. In order to be prime, you have to have 2 numbers. You have to have 2 numbers that'll go into it, and only 2. That makes it prime. And to be composite, you have to have more than 2. Well, our number 1 here, it doesn't fit any of those. So number 1 is not prime and it is not composite. 1 is just 1. So we'll put up this anchor chart just to help you remember how we find prime numbers, a number that only has 2 factors, one in itself. Here's another example. The first 4 prime numbers are 2, 3, 5, and 7. Now remember, our definition of a prime number is that it only has 2 factors. So remember, only thing that'll go into 2 is 2 and 1. The only thing that'll go into 3 is 3 and 1. The only thing that'll go into 5 is 5 and 1. The only thing that'll go into 7 is 7 and 1. So what are the, so you've got 2, 3, 5, 7. What are the next 4 numbers? Pause it. Work it out. Okay, so if you were to take 7 and just start counting up to 20, then you can look at all those numbers and you could start eliminating those that have more factor besides just itself. For example, 9 has 9 and 1. It also has 3 and 3. Right? So we know that 9 doesn't work. We know 8 doesn't work because of the 4. We know that 10 doesn't work because 5 will go into it. But what will go into 11 besides 11? Nothing. So 11 is a prime number. That would be our next prime number right here, be 11. We go to 12. Well, we know 6 and 2 go into 12, and 3 and 4 go into 12, so that's composite. 13. What will go into 13 besides 13? Nothing. So 13 is our next prime number. 14 can be divided by 7 and 2. 15 can be divided by 3 and 5. 16 can be divided by 8 and 2 and 4 and 4. So that doesn't work. 17 can be divided by 17 and 1. Oh, only 17 and 1. So that's going to be a prime number. 18 can be divided by 9 and 2. So that doesn't work. 19, let's see here. What will go to 19 besides 19 and 1? Only 19. So 19 is our next prime number. And then 20, of course, is composite because 5 and 4 and 10 and 2 will go into 20. So there's your answer right there. It's going to be these last 4 will be these ones here. The 11, the 13, 17, 19. Those are called prime numbers. And you're going to have to memorize the first 25. And when you do that, you'll get a badge. Plus, you'll also be that much better at doing mathematics. Here is the list. You'll want to write this down or take a screenshot of it and just memorize them. There's only 25 of them. They actually kind of flow pretty good. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. And you're done. That's all the prime numbers up to 100. Memorize these, come in and pass them off with me. I'll give you your badge and you'll be awesome. All right, that's it. Thank you. We will see you tomorrow.